Hello again, grade 12. So today is lesson 7.5, which is sort of wrapping up all of chapter 7. This is the last lesson in the chapter, and it's called Making Connections. So on your handout, you'll see this word problem written there. So it says, a small town in northern Ontario called Decimal Point has a population of around 5,000. It has a surplus of $50,000 to invest to build a recreation center for its growing population. The two best investment options are described below. So first we have Lakeland Savings Bond, which has an interest rate of 6.25% compounded annually. And there's a condition on that that loan, that investment. It says if the money is withdrawn before 10 years are up, there's a 2% of the initial principal penalty. So they'll have to pay an extra 2% off the initial principal. The second investment option is Northern Equity Mutual Fund, and their interest rate is 6% compounded semi-annually with no conditions. So as part of letter A, which says construct an algebraic model that gives the amount A as a function of time t in years for each investment, I'm just going to refresh your memory on the equation or the formula that we use to calculate interest. So the general formula is A of t, or the amount as a function of time, equals P, which is the principal, times 1 plus I, the interest rate, to the power of nt. So I'll say what each of these mean. So P is the principal. I is the interest rate, but it's divided by the number of periods per year. So what that means is if the interest rate is 8% and it's compounded semi-annually, so twice a year, then we would divide it by 2 here. So we would put 0.04 there instead of 0.08. And then NT is the number of compounding periods per year times T, the number of years. So N is the number of compounding periods per year, and T is time in years. All right, so that's the general formula we use to calculate interest. So for these two investment options, the Lakeland Savings Bond and the Northern Equity Mutual Fund, we're going to create an equation for each of those. So we'll start with Lakeland. So the amount as a function of time equals the principal. So the amount we're investing is $50,000 times 1 plus the interest rate. So the interest for Lakeland is compounded annually, so we don't need to divide it because it's just compounded once per year. So the interest rate is 6.25%. So as a decimal, that would be 0.0625. And that's to the power of NT. The number of compounding periods per year is 1, so it would be 1T. So I'll just write T. And then for Northern, we have the amount as a function of time equals the same principal amount, which is $50,000, times 1 plus, so the interest rate is 6%, but it's compounded semi-annually. So the periods per year would be 2. There's 2 periods in the year because it's compounded twice in 1 year. So we need to divide the interest rate by 2. So 6% divided by 2 would be 3%, so 0.03. To the power of NT, where N is the number of compounding periods per year, so that would be 2 because it's compounded semi-annually, times T, which is the number of years. Okay, letter B says, which of these investment options will allow the town to double its money faster? So we're going to calculate for each one how long it will take to double the money, and then we'll compare the 2 times. So we'll start with Lakeland. So if we were to double our money, that would put us at $100,000. So $100,000 equals 50,000 times 1.0625 to the power of t. So I'm going to begin by dividing both sides by 50,000. $100,000 divided by 50,000 is 2. So since we're doubling our amount, we could just have written 2 equals 1.0625 to the power of t. Because we're doubling, we don't even need to know what the principal amount was. But since we know it, we can also calculate this by writing 100,000 in the amount spot. So now we have 2 equals 1.0625 to the power of t. So we don't know what the exponent is. So in order to figure that out, we'll have to use log. So we can take the common logarithm of both sides. So that will leave us with log 2 equals log 1.0625 to the power of t. But what logarithm allows me to do is bring that t down to the front. So I'm going to write the t in front of log 1.0625. Now in order to isolate t, I'm going to divide both sides by log 1.0625. So t equals log 2 divided by log 1.0625. And if you do that in your calculator, you will get 11.4. So it will take 11.4 years to double the investment using Lakeland. Now we'll calculate how long it will take using Northern. So again, double the amount would be $100,000 equals $50,000 times 1.03 to the power of 2t. That's our equation we made in part A. We'll divide both sides by 50,000 again. So now we'll have 2 equals 1.03 to the power of 2t. Again, we'll take the common logarithm of both sides. So log 2 equals log 1.03 to the power of 2t. And again, log allows me to bring the 2t down to the front. In order to isolate t, I'll need to divide by 2 as well as log 1.03. So since I'm dividing, I can do that all at once because I'm dividing both of them. So divide by 2 log 1.03, divide by 2 log 1.03 equals t. So in your calculator, log 2 divided by 2 log 1.03, you may need to use a bracket around the 2 log 1.03. And you should get 11.7. So Lakeland took 11.4 years and Northern took 11.7. So therefore, Lakeland will allow the town to double its money faster. All right, part C. If the town needs $80,000 to begin building the recreation center, how soon can work begin? So how long will that take to get $80,000? And which investment option should be chosen? So we're going to calculate how long it will take to get $80,000 from Lakeland and how long it will take to get $80,000 from Northern and compare those. And then we'll take into consideration the conditions that are part of the Lakeland investment. So starting with Lakeland, we have $80,000 equals our equation from part A, $50,000 times 1.0625 to the power of t. We'll divide both sides by $50,000. $80,000 divided by 50,000 is 1.6 equals 1.0625 to the power of t. We'll take the common logarithm of both sides, so log 1.6 equals, bring that t down to the front, t log 1.0625. In order to isolate t, I'll divide both sides by log 1.0625. So using your calculator, log 1.6 divided by log 1.0625 is 7.75 years. So in order to get $80,000 using the Lakeland investment, it will take 7.75 years. But the condition stated that if the money was withdrawn before 10 years, they would have to pay a 2% penalty of the initial principal. So the initial principal was $50,000. So a 2% penalty of that would be times 0.02, which is $1,000 penalty. So that means they would actually need $81,000 before they could use this $80,000. So we need to calculate this again using the $81,000. So $81,000 equals $50,000 times 1.0625 to the power of t. We'll divide both sides by the $50,000 again. 81,000 divided by 50,000 is 1.62 equals 1.0625 to the power of t. Common logarithm of both sides, log 1.62 equals t log 1.0625. Isolate t, divide both sides by log 1.0625. So if you put this into your calculator, log 1.62 divided by log 1.0625, you will get t equals 7.96. So it'll take 7.96 years to get $81,000, or the $80,000 that they need from Lakeland. Now let's compare with Northern. So $80,000 equals $50,000 times 1.03 to the power of 2t. Divide both sides by $50,000. 80 divided by 50 is 1.6 equals 1.03 to the power of 2t. We'll take the common logarithm of both sides. Log 1.6 equals 2t log 1.03. In order to isolate t, we'll divide both sides by 2 log 1.03. In your calculator, log 1.6 divided by 2 log 1.03 equals 7.95. So Lakeland was 7.96 and Northern is 7.95 years. So just slightly, Northern will get them $80,000 faster, and that's only because of that condition that was put on the investment from Lakeland. So therefore, they should choose Northern. It will take 7.95 years. All right, and that completes the lesson for today. So just let me know if you have any questions, and have a great day.